Okay, now we have done the qubit of the determine input amount reaction, and we have written the qubit values in nanograms per microliter here on the board. The low input sample, which we have over here, as we suspected, they are not that low input, but that's fine. Our standard input samples gave us these values, and to figure out how much DNA we have in the 10% aliquot, we take the nanograms per microliter value and multiply by the volume of the final eluate. So that gives us, in 20 microliters of this reaction, we have from 100 to 500, basically, nanograms in the reactions. For the low input, we have around 200 nanograms on the 10% aliquot. So if you look in the manual protocol, you see that the kit specific says that you should try to aim between 500 nanogram to 5,000, right? So then we have to determine which aliquot are we using to be within that range. So for the number 6, we already have 500 nanograms, so we could start with the same aliquot. We can just pick the 10% and then we're good. For the other ones, we need to go up a bit. So to have a 20% aliquot for these ones, you are here and there you are kind of closer to the 500 mark. For that one, which is 122, we'll have to take from the larger aliquot, 50%. And yeah, maybe 50% is too much. Let's try with the 300. We take 300 microliters, which will be the 30% aliquot, and then we spin it down and see how large is that pellet. Because if you read on the start of the prep, you'll see that the pellet we are using should not occupy more than 20 microliters.
Okay. So
yeah.
And you compare it with a tube of 20 microliters.
Yeah. So we can make a tube and make a mark on it with some liquid to see this is the level of the 20%, and then we compare the tubes aliquot we are making to make sure that we are not overshooting too much there, because then you are depleting the chemistry and all that. So if I would to guess, I would suggest that many of them will go as the 20% aliquot due to the volume constraints. But let's see if we can squeeze the 300 or something like that on the really low ones, which is number 1 and number 4. At the same time, we see that we had some variable input. We had 50 milligrams almost, something like that for that one. And we had around 100 for the other ones. So there is some system in our madness, which is good. It means that we have done a good job with the crushing and the rest of the things. So good job.
Thank you. Thank you.
So I think
do a quick spin of the pellet in the microcentrifuge.
Okay, good. Yeah. Now, compare it. Well,
This one.
It's close enough.
It's very close.
Yeah.
It's very close, isn't it?
Yeah. What about the 40?
I think so. Maybe there's a slight difference but I think more or less.
So the 40 is also not that big.
Okay.
If you see Graeme is holding it up there. And now you see, so the 40 might not actually be 40. So now you see the differences in that you are taking aliquots of this large 1 ml thing. So it's very important that you mix it properly before you take out you mix immediately to take out the aliquots.
Okay.
Still, if there are some clumps and it's not fully homogeneous, it will be different amounts in the aliquots. So that's why it's important to have this fully suspended as a homogeneous solution. But anyway, we are good. to continue because we have up to 20 microliters of cell suspension. Okay, let's continue with the lysis.
Okay. Let me